since you guys already know how to put this into your calculator, I'm going to go ahead and ask you to do that on your own. So go ahead and find both the chi-squared value and the p-value for me on your own. The chi-squared value that you should have gotten is 8.63, whereas the p-value will be 0.070. Oh, that one's a tough one to round. So it's 0.7099 ... So 3 sig figs means that our third sig fig would be here, right? So that'd be 0.0710 is 3 sig figs, which is very weird, but it's because this would have rounded up to 10. And so to still make it 3 sig figs, we would have to put in that extra 0 at the end. But if you get a question like that in a test where it's like, that would be tough to round for you, you can always notice that what I did is I scrolled over it to see if sorry, that was my phone. I wanted to see what more decimal places there were. You could have just done 0.70994 and just rounded it to that many sig figs, because remember, you can always do more than 3 sig figs if it doesn't specify. Anyways. So that's our chi-squared value and our p-value. Remember that your degrees of freedom is always one less than the number of options that you have. And so since we have 5 options, 1, 2, 3, 4, 5, we take one less, and so then that will be 4. So the degree of freedom is 4, which you'll notice I put into here. Observed, expected, and then those should be the values that you get. Okay, so then now in order to draw the conclusions, we need to either compare the p-value with the significance level or the chi-squared value with the critical level. Notice we are not given a critical level here, right? Or a critical value. And so we aren't going to be using our chi-squared value, but it's still good to put it down, as well as our degrees of freedom. Those are still things that you should write down, even if you don't end up using it for your conclusions later on. So since we only have the significance level, we will compare that with our p-value. And since our p-value is, notice, less than 10%, we reject the null hypothesis. So if p is low, reject the h sub o. So that means that it does not follow the distribution. It could still follow a normal distribution. It just might be a normal distribution with different specificities. Okay, last example. We have all of this information, which says that we've got a supermarket, 6 counters available. Each counter is staffed by a cashier. The manager wants to understand whether the customer selection of counter is a uniformly distributed distribution. The following table shows the results for the sample of 180 customers on a random day. So the values that are given to you are always the observed. Notice that our first thing that we're asked to do is to fill in our expected values. This is a different type of distribution that we could be given, right? So we've practiced one with a percentage being given to us. We've practiced one with a type of distribution like normal or binomial given to us. Now this one talks about uniformly distributed. In other words, evenly distributed. That means that we want to have the same number in all of these for our expected. So our expected out of 180, if we want the same number, we do 180 divided by 1, 2, 3, 4, 5, 6, which is 30. So that means that there's 30 in every single one of here for our expected. If it ended up giving us a decimal place for an evenly distributed option, then we would have put the decimal. But it ended up being a nice whole number, so it works. Okay, I want you to try doing sorry, the hypotheses on your own. Remember that your null hypothesis is always that the sample follows the expected distribution. So in this case, this sample follows an even distribution. So then the alternative would be that it does not. The degrees of freedom, it just says write down because it should just be pretty quick. We have 6 options, which means it's one less than that. So our degrees of freedom is 5. And it says use your graphics display calculator to find the chi-squared statistic and the p-value. So I'll have you go ahead and do that on your own. Give it to me in 3 sig figs, please. Your chi-squared value should be 3.53, and your p-value should be 0.618. If you did not get those answers, make sure that you put in the right degrees of freedom. Make sure that you put in your numbers correctly. This is your observed, this is your expected, and they should go into a new document, into separate columns. So if one of those things is bound to be off if you got the wrong numbers. Okay. Then it says the critical value is this. Write down a conclusion for the test. So they gave us a critical value, which means we are comparing this to what? The critical value is always compared to our chi-squared value. So chi-squared is 3.53, which is definitely less than our critical value. And since our chi-squared value is less than the critical value, if p is low, we reject the h sub o, so it's opposite. So chi-squared low, we fail to reject. We fail to reject the null hypothesis. In other words, we're accepting the null hypothesis. And since the null hypothesis is that it does follow an even distribution, that means our sample follows a uniform distribution. And take a look, our observed versus expected, right? They aren't the same, right? It isn't equal all the way across. But what our test is doing is they're saying, is the difference between these two numbers, is it statistically significant enough for us to say that they aren't evenly distributed? For us to say, hey, there's an issue with these numbers, they should be evenly distributed, and they're not. And this test is saying, hey, you know what? Essentially, it's fine, right? It's not that big of a deal. Okay, good job today.